And I thought I'd begin by really just linking the Institute of Mining to a conference around Northeast Resources by really talking about a mine in the Northeast, and that's the Boddy polyhalite mine, so a mine down in Teesside. The polyhalite mine is the world's only polyhalite mine. It's the deepest mine in the UK, and it's the second deepest operational mine in Europe, with a maximum operating depth of about sort of 1,400 meters. And I was fortunate enough to visit this mine a few years ago. And believe me, when you're sort of 1,100 meters underground and the mine stretches out beneath the North Sea, we were 7 miles out beneath the North Sea, 7 miles from the bottom of the shaft. That is your only means of access to the surface. You're drilling in a material that's highly soluble beneath the North Sea. It's quite a sobering experience. It's not one for the faint-hearted. I couldn't do it every day, and I've got a tremendous amount of respect for the miners that do that on a daily basis. But that's our group there in the top of the top right-hand side. It does look like a rather aged Dutch pub football team, but that is the personal protective equipment that we had to wear before we went down the mine, and essentially it was shorts and a t-shirt. And the reason for that is because when you get down there, it's hot. It really is hot. So the operational temperatures at the bottom of the mine, it's about 40 degrees. In the deeper parts of the mine, it can get closer to 50 degrees. And for me, that was a really physical example, a privileged example for me to experience geothermal heat. The deeper you get underground, the hotter it becomes. So that hopefully brings us nicely onto the subject of my proper talk today, which is really the geothermal potential, and particularly the geothermal potential of the Northeast. I'll begin with just a very brief introduction to geothermal and some of the terminology that we'll use. I'll then focus the main part of the presentation on a white paper that I was involved with, which really looked at unlocking investment and potential of geothermal in the UK. And then I'll talk a little bit about a bit of work that ARUP were involved with, focusing on the potential in the Northeast itself. So very simply, as I learnt at Boddy, the deeper you go underground, the hotter it gets. The global average geothermal gradient for every kilometre you go underground is about 30 degrees. It's a little bit lower in the UK, around 26 degrees, but as we'll see later on, there are 1 or 2 areas where in the UK that temperature gradient is a little bit higher. And there are various ways in which we can access that heat beneath our feet. On the left-hand side, we can use shallow geothermal systems to access the lower grade heat at shallow depths. This is a technology that's been in use in the UK for a couple of decades now, so it's commonly used. At shallow depths of 10 to 15 meters, we can use the benefit of the fact that temperatures in the ground are relatively constant compared to the temperatures above ground, so we can provide cooling in the summer, heating during the winter months. And we essentially use sort of ground source heat pumps or heat exchangers to take warm water out of the ground, pass it through a heat exchanger, heat up a secondary fluid that can then be used for direct heating in a building. We can use closed loop systems which circulate cold water down a pipe and then heat it up in the ground and bring it back up again through that continuous loop. Or we can use open loop systems where you're extracting hot water from one well, taking that out of the ground, using it, and then recharging cold water via a second well and allowing that to warm up and then creating the cycle. And then also sort of more recently, we've got some really innovative schemes using that same sort of underground heat from mine water. So we have a scheme over the water in Gateshead now, which is powering a heat network with heat from a 150-meter deep shaft. So they're shallow geothermal systems. Whereas there's a lot more interest now in deep geothermal systems. And when we talk about deep geothermal, we probably tend to talk about depths of 500 meters and beyond. But really, we're really focusing on the temperatures that start to become higher temperatures, 70, 80, beyond degrees C, which enables us to use sort of heat for direct purposes rather than having to pass it through a heat exchanger. And then obviously the ultimate goal for many is to then look at the highest temperatures that we can then start to think about generating steam that we can use for power generation through turbines as well. But as we talk about geothermal energy, I do really want to sort of think about both things. I don't want us to just get focused on electricity generation from geothermal, that the heat that we're bringing out of the ground is a fantastic resource and we need to make best use of that. So that's just a very quick overview. So I'd like to now just very quickly run through the white paper that I was involved with. And the purpose of this was all about sort of unlocking that geothermal potential in the UK. So the piece of work was funded by the Department for Energy Security and Net Zero, DESNZ, and then it was delivered through the North Eastern Yorkshire Net Zero Hub, thank you, Chris, and also the North East LEP, really sort of helping to support the fact that the North East, alongside our academic institutions, is a centre for excellence for geothermal energy. And I was very privileged to be named as one of the authors alongside Dr. Karina Arbessa and Andres Gonzalez Quiros from the British Geological Survey. The BGS led the piece of work and ARUP supported them in delivering that. So as I mentioned, the purpose of the white paper was really to sort of focus on how we unlock potential. So in writing the paper, we provided an overview of sort of the potential across the UK via a series of thematic maps, which I'll run through shortly. We then went through a relatively extensive stakeholder engagement exercise with the geothermal industry, looking at opportunities and benefits alongside challenges and constraints that are really inhibiting that development. And then the outcome of the white paper was a set of recommendations that were then put to central government and to industry to really try and unlock that potential. So just having a quick look through then at some of the thematic maps that were produced in the report, and I'm pleased that it sort of echoes the slide that Stuart showed us at the start of the presentations today. So this is just a very brief overview of some of the geothermal resources in the UK. And when we're looking at the geothermal potential, we're really looking at our deep sedimentary aquifers as being the principal geothermal source. So, we've got great coverage in sort of the northern England from a lot of those deep sedimentary basins, as well as some of the thermogenic granites that we have in Cornwall, up in Aberdeen, but then also in sort of in the Weardale area as well. You can see in the central part, but really encouraging from a northeast perspective to see that we do have tremendous potential. And then the paper also made some very rough estimates as to the amount of heat in place in each of those particular reservoirs to look at the overall capacity that we have in the UK. And when we just try and put some of those numbers into context, so in terms of the amount of heat in place, there was an estimated sort of 500,000 terawatt hours of heat within those reservoirs. And if we compare that to sort of estimates that were made for the UK sort of annual space heating demands, I think these are slightly older figures, but they were estimated at 200 to 300 terawatt hours per year. So you can see we're 3 orders of magnitude, 1,000 times greater in terms of the heat potential that we have in the ground in terms of our comparing that to our heating needs. Now, I'm not trying to put any illusions in place. Heat in place is not heat in the ground or heat delivered to a building, but it's just a great example of the tremendous potential that we have in the UK. And then we went to look at each of the specific areas and each of the basins around the UK in more detail. So I've just focused here on some of the plots from northern England. So again, looking at our sedimentary basins. Fantastic to see that we've got sort of concentrations of resources both in the Tyne Wear conurbation and in Teesside, as we can see in the plots on the right-hand side there. And then we also tried to link the potential for heat to end uses, and the plots on the right-hand side relate hospital locations across the northeast to locations of geothermal potential. And there's a fantastic opportunity where we have hospitals and NHS infrastructure that has a relatively steady demand for heat and hot water that could be powered by geothermal resources. So we did look at that in a little bit more detail, and a basic estimate of the 200 or so NHS hospitals that had the greatest heat demand, more than half of them were sitting on top of potential geothermal aquifers. And if we looked at just the top 30 hospitals with the highest heat demand, if they could have been, if they could get their heat from geothermal sources, that could reduce the carbon emissions from the NHS estate in England by 12%. So significant savings that could be achieved by geothermal, just with one simple example. To also help sort of try and help organisations gain better understanding of that distribution, we then sort of mapped geothermal potential by local authority districts to give local authorities a good understanding as to whether their particular geography has good geothermal potential, and they're an excellent source again for geothermal use around council buildings, public facilities and their estates. And then we also wanted to look at sort of the potential social benefits of geothermal energy as well. So this particular plot looks at the IMD index of social deprivation and looking at particular areas that could benefit from geothermal heat. So again, this was an area where we focused on Tyneside, socially deprived areas in the Tyne and Weir area, and how well they link to areas of potential heat networks, geothermal potential, where there's, again, another fantastic opportunity for us to look at providing sustainable, continual heat to areas where it's really needed. So having summarised sort of the potential in the UK, the main thrust of the paper was really around sort of stakeholder engagement to identify, what are the challenges that industry is encountering that are preventing greater, more wide-scale investment from the geothermal sector. So we did a variety of sort of stakeholder engagement exercises, looking at, we had a virtual stakeholder workshop. From that, we sort of prioritised a series of actions. We then created an online stakeholder survey that we sent out to a wider range of people and used that process to sort of help us prioritise some of our actions and mitigations. We had a series of focused one-to-one interviews with geothermal developers, funders, regulators, to understand what specific challenges they'd had and how that might inform our development. And then sort of on conclusion of the piece of work, we then had a thorough workshop with our stakeholder engagement group, sorry, our steering group, to make sure that we were robust in the assessments we were making and could respond to the challenges that they put to us after the piece of work. So the stakeholder engagement was across a broad sector of industry representatives, from those involved in delivering geothermal projects to academia, to contractors, consultants, energy companies, financiers, to really engage with everyone who was involved in that particular process. So we had 23 different organisations at the workshop. Our online survey went out to 154 people. So we had a good amount of input from a wide diversity of sources. And we'd also use sort of feedback from the Environmental Audit Committee on geothermal heat and power, which had been reported later on in 2022. So that again gave us a really nice diverse data set to work from. And so from our workshop, we'd identified a series of challenges. We asked our online survey to help us try and prioritise those challenges. It may come as little surprise that one of the greatest challenges was capital cost. So there's a very high capital cost associated with drilling a geothermal well. There's a high capital cost with a lot of renewable energy technologies at the moment. But obviously, there is a certain amount of risk associated with that in terms of the drilling risk, as well as then the risk of the yields that you'll get from that particular well. So capital costs were a key challenge, alongside then sort of the funding mechanisms that can support geothermal to overcome that, that initial investment. So a lack of policy support, a lack of subsidy support for the geothermal sector. And then also, again, on the commercial side, the challenges around risk and insurance. So how do you ensure the drilling risk of completing your well, alongside how do you ensure the risk of a poorer yield than you're expecting? So I think geothermal developers that were going through those projects were finding those particularly difficult issues to deal with. So alongside those, perhaps sort of the commercial costs as being the main challenges to begin with, there are also issues then around sort of data as well, the lack of availability of data at the present time, and really how as an industry we can make better use of data sharing to help facilitate future investment and development. We also asked about sort of the geothermal understanding, and our respondents were sort of very confident of the understanding of geothermal within sort of the geothermal sector itself, within the developers, good confidence within energy companies. But then as we sort of spoke to sort of end users, policymakers, that message was becoming more and more diluted. So there's a really important piece of work for us to get that message across. So being able to speak today to a very diverse and varied audience is really helpful, so thank you. We really need to start making better use of getting the message about geothermal and its potential out there to those that are investing in these projects and those that are writing the policies around them. And then we also then looked at sort of the key actions that we should be undertaking. We put a list out again to our survey and asked them to prioritise those. And a very sort of clear front runner was the need for geothermal to be clearly stated in government strategy in our approach to net zero. It doesn't get the place it deserves alongside other renewable technologies, and that's something that we really need to try and change. And then also looking at then how we can get better clarity on the right financial models to develop the geothermal sector. And then beyond that, looking at how government can perhaps help overcome some of those commercial challenges by helping sort of fund demonstrator projects, prove that technology of deep geothermal with real delivery to help sort of ease that investor challenge that we see at the moment. And then the graphic on the right-hand side does just show that there was some relatively varied responses as we came through some of the different options, but the clear government strategy, as you can see, was the first choice of the priority of the majority of people. So when we came to pull our recommendations together on the white paper, we really looked at trying to sort of range them over appropriate timeframes. Now, again, this is sort of an indicative program, but we're calling sort of short-term actions really something over the next 5 years. I mean, 5 years doesn't sound like a particularly short term to a lot of us, but when we're trying to develop what might be a new and emerging technology, we need to have enough time to get these projects in the ground, learn from them, and then help to develop the sector going forwards. It was really interesting sort of watching Tom's presentation this morning. The first offshore wind turbines were built just off the coast of Blyth about 20 years ago, and we now have a globally leading offshore wind industry. So in 20 years, we've come a long way with offshore wind. So, we're a long way behind the curve in geothermal. But it takes that long amount of time to come up with an industry where you then have a mature industry that's innovating, improving on its delivery. So the timescales, I think, are indicative. I would love those timescales to be shorter. And really, I think the recommendations that we make should be reviewed in terms of how quickly industry matures. But as I say, we wanted to try and put some sort of context on what is reasonable and credible for short-term, medium, and long-term investments. So the 6 recommendations that we came up with, firstly, these are very brief summaries of the recommendations. So I would like to refer you to the white paper itself for a bit more detail. But firstly, the financial support, fundamentally important. We need clear mechanisms for financial support to really encourage that step change in investment at the point in time we are at the moment. As we look forward and as the industry starts to mature, as risks become better understood, and as we become a more sustainable sector, then we can then look at changing those financial models as as time progresses. Government strategy, I've already mentioned before, so a really quick short-term action of improving that invisibility now. But then, as we get to the longer term, we want to put some really sensible strategic growth goals in and targets for what should geothermal deliver for the UK. I'm sure that'll be a question from the floor today is, what could we achieve? But we really need to get that sort of, we need to get over that threshold of having a number of schemes on site which are already delivering, and we're not quite at that point at the moment. Accessibility of data, lots of actions there. So an immediate action of sharing the wealth of data that is already held by organisations like the BGS and the oil and gas sector, making those readily available for the rest of industry to help reduce some of the high investigation costs that we currently see. Sharing that information via a common data platform, something that Mark Island may speak about later on. He's done some great work at Newcastle University on that. And then really looking at government funded exploration programs to plug some of the gaps in knowledge that we have, alongside sort of data sharing obligations for developers, so they are forced to share their data with the wider industry for everyone's benefit. Actions around regulation and licensing. Again, we don't have anything in place at the moment, so as industry matures, starting to think about having central licensing bodies. And then the final couple of points are really around the perception of our industry. So firstly, from a public point of view, we need to better engage with the public to tell the story about geothermal, perhaps overcome some of the concerns that may exist from sort of fracking and microseismicity from deep drilling exercises. So geothermal is very different from fracking in terms of it being a green sustainable solution. So we do really want to promote that. But then also a geothermal voice, our final point there, that the industry needs to be a little bit more connected in the way that it communicates, it shares its knowledge, its research, but the way it communicates with policymakers and the wider industry to provide the advice to help us with some of these key changes. That's just a very brief overview of some of those actions. And one of the final points of the white paper was really around creating a geothermal energy deep route map to help developers understand the stages that they need to go through for development. So just finally now, just a very quick look at the Northeast. So ARUP were involved in a city decarbonisation delivery plan for central government, looking at a variety of cities across England. Newcastle was one of those. So we looked at a variety of different sort of geothermal sources, looking at shallow ground source heat and the potential that has across the Newcastle area. There was sort of low to medium potential due to the overlying sort of low permeability drift deposits, but then that increases with sort of localised variations to geology, as well as then the good potential that we have with mine water heat recovery. And then when we look at sort of deeper geothermal, we are fortunate in the Northeast that our temperature gradient is higher than our sort of global average. The indications were around sort of 34 to 40 degrees potentially per kilometre, so significantly better than seen elsewhere. And then that really leads us on to sort of there being sort of great potential within sort of the Tyne Wear conurbation for deep geothermal heat, both from a heating perspective, but then also that elusive power generation as well. So again, I think some simple calculations were presented that, depending on depths of reservoirs and areas, the potential from a single well that you could be generating somewhere between 1 and 6 megawatts of electrical energy from a single geothermal well drilled here in the Northeast. So something comparable to a medium-sized wind turbine, for example. So then in conclusion, hopefully I've managed to get the message across that there is excellent potential in the UK and specifically here in the Northeast on geothermal heat and power, but let's not just get focused on that power bit, please. Clear government strategy is essential, as well as sort of clear financial support from government to really kickstart the industry. We must improve investor confidence. So we've got pilot projects that are currently being drilled now. So there are 2 projects in Cornwall, 5 kilometres deep, supplying heat. One of them will shortly be supplying electricity as the first geothermal power plant in the UK. That will improve investor confidence. And I would like to appeal to those investors that are here today. Please help us deliver this industry. Be brave. It is a proven technology. We just don't have the experience. Well, we have the experience in the UK. We just don't have the projects. So, it is proven. The rest of the world is doing this, and we're behind that curve, and we need to catch up. And then finally, we need to really start thinking about investing in our urban infrastructure to help deliver some of this renewable heat. One of the challenges of the Stoke project, which is on site at the moment, is the drilling is going to be finished, it's going to be ready, but they can't dig up the roads quick enough in central Stoke because of congestion to actually put the heat network in place. So, let's start thinking ahead. Let's get the systems ready for using geothermal heat because it's on its way.